this is Avni Padada. For my DSP laboratory experiment number 8, I have made a GUI for window analysis. This is the layout I'm working with. I have a window. I'll select window from the drop down menu. Then we have length, which should be odd, 2m plus 1, which we'll be using. We'll input it here. Then we'll use the go button to complete for running the code. When the code runs, we'll have our main lobe gain shown here, main lobe width shown here, side lobe attenuation and transition width. Will also have two plots, one of discrete time spectrum of the window and the magnitude spectrum of frequency response of the spectrum here. Now I'll show you the code behind it. So we have this Windows GUI function because I have saved the figure as Windows GUI, so we'll have same here. And so in Windows GUI function, first we'll have this opening and opening function initialization codes, which we can't edit. We'll have to put inside that there's a opening function and output functions. Then there are these functions related to the components I have put, like this window type, this will be length, this is main lobe dB, this will be main lobe hertz, this will be side lobe dB, and this is transition with TW. This go button is as go. We have named the plots axis as DTS and magnitude mag spectrum, so we'll be using it. So first we have like window type callback, window type create functions. We have left them as it is. We have length callback. We'll just once check if the length is empty. If it's empty, we'll set it to 0 again, and we'll leave it at that. Then length create function is there. Main lobe dB. This is for callback and create function of main lobe gain. This is side lobe dB, side lobe attenuation, callback and create function. Then we have main lobe hertz will be the main lobe width of callback create function, and transition width, transition create function. Now here is the main part of the code, where is go callback button. When we press the go button, then this code will work. That's why we have first have got the X from the will change the string to double, from get handles dotted to string, will get the string and will change it to double as the value of X. This X will be the length we are inputting, and this will find M from here. Then will define angular frequency omega from 0 to pi minus 0.001 with 1000 like 1000 samples. Then we have small n from -m to m, and for the DTS angle we'll do this. First we'll get the handles window type value from the drop down menu. If it's the first case, which is rectangular window, we'll have this function for the rectangular window. Then case 2 is the triangular window, case 3 is the Hanning window, case 4 is Hamming window, case 5 is Blackman window, case 6 is Gaussian window, case 7 is sine window, case 8 is sine squared window, case 9 is Gaussian window, and case 10 is Welsh window. They have all defined all these according to their definitions. Then if we choose something, we'll get from here. Then I have defined one wind DFT of length length equal to length of W, and we have defined the DFT here by putting a temp and then sum of temp to get all the summations. We'll have DFT, and then we'll find the magnitude spectrum by doing 20 by log 10, which will give which will be 20 by 0. This is the function is 20 log 10 absolute wind DFT, but in log we have like basic E as that's why we divide by log base 10 to get the absolute value. Then we'll plot it in the window, chosen window with its n, and for another axis magnitude spectrum we'll plot the magnitude with angular frequency W. Next, to find the main lobe gain, first we'll find the minimas. So to find the minimas, um, we'll invert the magnitude as inverted mag, and using the function of find peaks, we'll have we'll find the locations of minimas as minima index. Then we'll find width of the minimum, first minima index will be the minimum, so it is the main lobe. To find we'll get the main lobe width with this, and by dividing it by 2 pi we'll get this width in hertz. If the width is empty, then we'll set the width as 0.5. If we have only one lobe, then we'll find the 3 dB point, which will be from 0 to when the magnitude is just less than minus by 3, and we'll divide it by 2 pi to get it in hertz. We'll find the maximas again by directly putting mag into find peaks, and if the maximus is empty, we'll find the end magnitude, so we'll have all the end maximas. Then we'll do the we'll find the side attenuation, so we'll find the maximum of the magnitude, and minus it from minus the first maximum from it, so we'll gain the side lobe attenuation. For transition width, we'll find the absolute difference between the width, which will be the main lobe width, minus the 3 dB point, which will the passband, to get the distance from the minus 3 dB point to the first minima. We'll have our transition width. Then in set handles.ml string, we'll put width, so that in main lobe in hertz we'll get the main lobe width. mldb will put maximum of magnitude, because at 0 it's maximum, and that is the main lobe value. At SLDB, we'll put the side lobe attenuation, and at TW, transition width, we'll again put TW, and that's the end of our code. Now, if I run our that code, so we'll have this GUI, which in the format we had made like this. So this is the GUI we're getting, just like what we did. Now, if we use it like a rectangular window, if you like rectangular window of length say 43, because it should be odd, and we use it, so the code works, and we'll have this chosen window. It's DFT magnitude spectrum, and the main lobe width, side lobe width, transition width. If we change this to triangular, we'll get different values. Triangular changes, its spectrum changes. If I go for Gaussian, let's say that we'll get the Gaussian Gaussian value and its DFT magnitude spectrum. If I change it to Blackman, let's say, then we'll get this for Blackman, the magnitude spectrum and all the values for Blackman of that length 43. For sine squared, we'll get for sine squared. Poisson will get the values as Poisson. So distribution will be according to it, and we'll have the main lobe value for it. You can see it's 29.20. Main lobe width will get in hertz. Side lobe attenuation will get in dB, and again transition width in hertz. That's what. That's it for the today's